You know, it doesn't really matter which one you use. This is probably the less complicated one. And we already calculated the perimeter, so it's pretty quick and easy to get the area here. Area would be 1/2 times the apothem, which is which number there? It's not 8. It's 6.5. Keep those straight. Remember, the radius goes to the vertex, right? The apothem goes to the side. And then the perimeter we already figured out was 46.64. So we just have to do that math. And it's approximately 151.58 units squared. Probably should have put units up here. It's not bright enough, or not, let me close this. Yeah, that's the word I was looking for.
Yeah, I've actually done
Is that better? Hopefully you can see it better. Okay, so the last one is a different situation again. Here, let's count how many sides are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? If it helps, write it down. Sometimes I do that just to make sure I don't screw up. 10 sides. All right, so we need to find the perimeter. That's easy because they gave us the side length, didn't they? So the perimeter is 7 times 10, which is 70. So easy on that one, 70 units. All right, the area, we have options. We have to do a little work for the area. So it doesn't matter what we find. Let's think of it this way. When you only have a side length, this is a little off-center, but you got to think about one of those triangles, right? And you either have to find the radius or the apothem. Let's just find the apothem. So I'm going to, first of all, figure out what the central angle is here. What is it? What is the central angle here? The measure of the central angle. 360, right? So the central angle, no, not 360, is 36 degrees. Right?
Wait, how?
Yeah.
There's 10 sides, 360 divided by 10. That's the central angle. Now, I'm going to take and write this triangle out here. I know this side is 7. If I draw the height there, that's my apothem. But then this angle right here would be half of 36, which is what? 18. So I'm working with this right triangle right here. Okay? I'm sorry, let me just adjust this. This imaging is weird. So if I want my apothem, if I want this, what trig ratio would I use? Here's my angle that I'm working with. Opposite over adjacent, but would I use 7? No, I would have to use 3.5. And I would use tangent, right? Okay. Do you all see that? I'm working with that half a triangle there. So this side length of that right triangle is 3.5. I need the height or the apothem, and it's 18 degrees because it's half of the central angle. I pulled this triangle. I'm looking at DJ's face right now. This triangle came from here, right? I just wrote it out here. I love your reading your faces. It helps because people don't say anything, but they sometimes just look confused. Which is good. It's fine. I get it. It's kind of a lot. It's a lot to absorb. So my A is going to be equal to the tangent of 18, which equals the opposite, which is 3.5 over A. And ultimately, I'm just going to cross that off. Ultimately, what you're doing is dividing 3.5 by the tangent of 18, aren't you? In the cross multiplying process, 3.5 times 1 divided by the tangent of 18 will give me A. I know I wrote that differently this time than I have before, but I just want you to see that because it might show up in your homework. So then you get that number. A is approximately 10.77. And I have the perimeter, so I can find the area using this formula. Yeah, we still haven't found the area. Area equals 1/2 times my apothem times my perimeter, which is approximately 376.95 units. Thank you. There was something I wanted to point out that I noticed when I was looking at your practice problems in the book. It's not a big deal, but if you go back to your formula here, they have this one also in the book like this. Isn't that the same thing? What is N?
Number of sides.
And what is S? Side length, right? Number of sides times side length is the same as the perimeter. So they have that written in there as well. It's not any different. N times S is really the perimeter. Okay? All right. So that is all. Are you ready?